Hi guys, welcome to the series of algorithms interview questions and answers. So this is first video in this series. I'm going to use JavaScript for the whole series because personally it is my favorite programming language. I'm trying to I'll try to explain the logic while keeping it is independent of the programming language. So you can choose your own language as you wish. So this question is about sorting a numbers array using bubble sorting algorithm. As you see, let's understand the problems first. We have a constant variable with the name a, which holds an array of numbers here. There are a bunch of numbers which are not sorted, um, and there is a function with the name bubble sort which takes one argument, and we need to write the code here. Before starting the coding, let's understand how the bubble sorting works. Let me open up a drawing board. I'll take one block here. Let me take a simple example. Let's say 5, 1, 4, 10, 6, 3. So this is let's take this example. This has 6 elements, right? And we so the bubble sorting for algorithm works with a bubble and a swap, right? A bubble will run on each iteration, and there will be a comparison of the adjacent elements, and if the comparison draws true, let's say the comparison between 5 and 1, if 5 is greater than 1, because 5 is before 1, right, in this order, 5 1 5 is before 1, and 5 is greater than 1 also as the number value. So we need to swap it because the order is wrong, and we are expecting it to be ascending order. I forgot to mention it in the start of the video. We need to do it in the ascending order of sorting. So 5 will be after 1, right? So on the first loop, 5 will be after 1. So I'll take a duplicate here on the for to represent the first iteration, and this will be 1 and this will be 5. Now these 5 and 4 will be compared in the next iteration, because we need to move the bubble. uh, so 5 and 4, when compared, 5 is greater than 4, right? And this will be 4 and this will be 5. And now 5 and 10 will be compared, and these two are already sorted, right? Because 5 is less than 10 and 5 is before 10 in the order, so no need to swap here. Now 10 and 6 will be compared, right? So 10 and 6, if compared, 10 is greater than 6 and 10 is before 6, so we need to swap it because in ascending order 6 occurs before 10, right? And now 10 and 3 will be compared. Again it's the same case. Now here it will be 3 and here it will be 10. Now as you see, the last element, which is 10, is sorted, right? And we don't have to do anything on this one, like there won't be any swapping needed for the last element. And the rest of the elements, if you see 5 and 6 and 3, they are not sorted yet. 6 and 3 are not sorted yet, right? So let's take one more copy of the latest iteration uh, array, and let's compare 1 and 4. Now 1 and 4 is already sorted, 4 and 5 is already sorted, 5 and 6 are already sorted, 6 and 3 are not sorted, right? So this will be 3 and this will be 6. and 6 and 10 are already sorted. Now if you see 5 and 3, they are not sorted, right? So we need to take one more iteration here. 1 and 4 already sorted, 4 and 5 are already sorted, 5 and 3 not sorted. So 3 will be here, 5 will be here. And 5 and 6 are already sorted, 6 and 10 sorted. And 4 and now if you see the result, 4 and 3 are not sorted. Let me take one more copy here. Compare 1 and 4 sorted, 4 and 3 not sorted. 4 is greater than 3, so 3 will be here. We're just swapping. And now 4, 5, 6, 10 are already in sorting order, sorted order. And 1 and 3, I guess, 1 and 3 is already sorted now. No need of any other iterations, but still the loop will go on because we still have one more element left here. And after this iteration, there won't be any change because there won't be any swapping needed. So this is how the bubble sorting will work. We are taking a bubble and compare it with the next element which is adjacent to it, and if it is great, if the adjacent element is greater, then we just swap it. So here we need to take two for loops. One is to do a bubble and one is to do a swapping. I'll take one first loop with the variable I must be less than arrow dot length I plus plus, and for swapping we need and one more loop. I'll take j here. J must be also less than length j plus plus. So we need to compare, right, error of j. If error of j is greater than error of j plus 1, which will be, so j plus 1 because we need to access the adjacent element next to the j here. So when j is 0, we need to compare it with the j plus 1 element here, with the index j plus 1, which is 1 here. So 3 and 1 will be compared. I'm talking about this iteration here, the j iteration. 3 and 1 will be compared. 3 is greater than 1, so swap, do a swap. How do we do a swap? We'll just take one temp variable and save it error of j, and error of j is equal to error of j plus 1. J plus 1 is equal to temp, and let's return the value result. So if you observe, we are accessing the adjacent element using j plus 1, right? What you might get a doubt, when j reached to end of the array, what will happen to j plus 1? Because that will throw an exception saying that index does not exist, right? Index is out of the bound, or index reached a maximum, something like that. To avoid that, we can do a -1 on the loop itself, right? So let's save the result into a variable. I'll call it result only, bubble sort of a. I'll just print it, console.log result. The list is sorted, right? But this can be improved. Let's see. So if you observe the example that we took here, on the first iteration the last number 10 is solved, right? Because 10 reached to the end of the list and it is the maximum of the list, right? Maximum value of the number. And on the second iteration, 6 is reached just before 10, and this is the next maximum after 10. and in the third iteration 5 is the next maximum, and on the last iteration 4 is the next maximum, and 1 and 3 are already sorted. So we don't need to include the sorted numbers, right, sorted elements once the iteration is done. So to avoid that, on the first iteration we need to check only these elements which are not sorted, right? So on the second iteration we need to exclude the last two. On the third iteration we need to exclude the last three. How do we do that? We just have to use this I value, because we have I also here, right? We'll just say minus I. That is all. This will give the same result, I hope so. Yes. And this algorithm is slightly improved if we exclude the irrelevant or already sorted elements, right? And that is it. So this is the first video in this series. I'll put all the videos in this series in a playlist, and I'll leave the link of the playlist in the description of this video. Going forward, I'll continue to use JavaScript, or you will see me using TypeScript in some videos, just to avoid some type errors in the future videos. Thank you for watching. In the next video we'll do one more sorting algorithm, that's called merge sort algorithm, which is very efficient, and in that video only we'll do a comparison between bubble sort and merge sort. Yeah, thank you. That is all.